morning, students. Myself, Dr. Eustace Russell. I'm working as assistant professor in the Department of Mechatronics Engineering at Sri Muthukumaran Institute of Technology. So far, we are seeing the subject called robot dynamics and control. In the previous class, we completed up to Unit 3. First 3 parts we have successfully completed, and we are in the last part of this same subject, that is robot control system. This subject we are studying under the regulation of 2021. The subject code is RA3601. We will see one by one in the upcoming slides. Robot control system. So far we completed the various internal sensors, stepper motors, actuators, various basic introduction part we have completed in the last 3 parts of these units. And today we will see, apart from that, what are the topics that is left out. We will see one by one. Internal sensor. Internal sensor measure the robot's internal state. They are used to measure its position, velocity, and acceleration. Position sensor. So what is that internal state means? The internal state. The internal sensor means measure its position, velocity, and acceleration. External means what are the obstacles that is present, what are the object that is in front of robot, what are the measures should be taken in order to avoid the accidents. The internal sensor, it is mainly used to measure its position, velocity, and acceleration. First of all, we will see the position sensor. Position sensor measure the position of the joint, the degree to which the joint is extended. So joint means, what is joint? Whenever the two links are added, we will get a joint. Two links combined together to form one joint. The degree to which the joint is extended, up to what it is extended. They include encoder. First is encoder, digital optical device that converts motion into the sequence of digital that is pulses. Whatever the motion that is there, that will be converted into pulses. Then potentiometer, the variable resistance device that expresses linear or angular displacement in terms of voltage. So that is variable resistance, whatever that is happening, that expresses the linear or angular displacement in terms of voltage. Then linear variable differential transformer, the displacement transducer that produces high accuracy. It generates an AC signal whose magnitude is a function of displacement of the moving core. So what is that? It generates the AC signal. Magnitude is a function of displacement of the moving core. Up to what the core is get moved. From that we will find out the accuracy from that, the displacement transducer. Then synchronous and resolvers. Velocity sensor, velocity or speed sensor measure consecutive position measurements at known intervals and compute the time rate of change in the position values. So what is that meaning of this? Is the speed sensor or velocity, the consecutive position measurements, under what position it is there, the changing of one displacement to another point. That is change in displacement with respect to time, we know the velocity. So at that known intervals, we can compute the time rate of change in the position values. Then acceleration sensors, then accelerometer, we will consider that. We will see what is accelerometer, how it is functions. Accelerometer measures acceleration. According to the name itself, it is to measure the acceleration, that is change in speed. Acceleration is nothing but a change in speed with respect to time of anything that is mounted on. Then how it is working means, inside accelerometer, EMS, the device, are tiny micro structures that bend due to momentum and gravity. When it is experience any form of acceleration, these tiny structures bend by an equivalent amount, which can be electrically detected. So we are having tiny micro structures that will be bent due to momentum and gravity, because due to the deflection we can study that how much what is the electricity electrically we can detect it. Totally accelerometer are easily and cheaply available, making it very viable sensor for cheap robotic hobbyists like you and me. What are the applications? We will see that it is widely used because they can sense a wide range of motion. They are used in the latest Apple phone books, and other laptops to detect when the computer suddenly moved or tipped, so hard drive can be looked up during the movement. They are used in cameras to control image stabilization function. They are used in pedometers, giant meters, and other exercise and physical therapy devices. So these are the main applications, because wherever the exercise machine we are using, the acceleration, this kind of sensor will be utilized to find the change in the velocity with respect to time you have to measure. Then physical therapy devices, whenever ECG test, there will be some equipment to check the patient, how much he is walking and running, the jogging with respect to time. They have to measure the change in velocity with respect to time. Then pedometers, also the same type. They are used in gaming controls to generate tilt data. They are also used in automobiles to control airbag release. You know that airbag that is in front of the dashboard, at the time of that sudden stop, whenever the sensor act that the change in that, automatically the airbag release will take place. There are countless other applications for also. Okay, the possible uses for accelerometer in robotics. First is self-balancing robots, tilt mode game controllers, model aeroplane autopilot, alarm systems, collision detection, human motion monitoring, leveling sensor, inclinometer, vibration detectors for vibration isolators, G-force detectors, axis of acceleration. Here we can see the axis of acceleration. We have already seen the first unit, we have seen the various coordinate system, that Cartesian coordinates system, under what workspace the robot will function, the various types we have seen. In this we will see one by one. The tiny microstructures can only measure force in a single direction or axis of acceleration. This means with a single axis measured, we can only know the force in either the x, y or z direction, but not all. Only single axis only measured. But at the time, all the forces is not possible. So if you say your x-axis accelerometry end on, a robot was running around and ran into the wall in the x direction, your robot can detect this collision. In the direction of the x only, the robot can analyze the collision. But if you say another robot rammed into it from the side, the y direction, your robot will be oblivious to it. So it is very difficult to look onto that. There are many other situations where the single axis would not be enough. It is always a good idea to have at least two axes more than that one axis. Then gravity. Everybody you have studied might have studied in your school days, acceleration due to gravity G, that is meter per second square. Everybody aware of that, the formula of the gravity. Now you will have a recall in that. Gravity is acceleration. Your accelerometer will always be subjected to be 0.91, minus 9.81 meter per second square acceleration. Negative means towards the ground. Whenever the object is facing towards the ground, so it will be the positive value. So whenever it is passing away from the ground, it is negative value. So that's why, because of this, your robot can detect that angle it is in the respect of to the gravity. If your robot is a biped, then you want to be always remains balanced and standing up. Just simply use a two-axis accelerometer. As long the x and y axis detect zero acceleration, this means your robot device is perfectly level and balanced. Then accelerometer rated G. When you buy your accelerometer, you can notice saying that rated as 2G or 3G accelerometer. This is maximum G force your sensor can report. Gravity accelerates objects at 1G or 9.81 meter per second square. For example, if your robot is moving at 1G gravity upwards, then that means your sensor will detect 2G. That's the 2 times of that it will measure it. For most robotics application, a 2G rating will be fine. So why not just getting the highest rating possible? Means the lower the rating, the more sensitive it will be to the changes in the motion. You will always have a finer tuned sensor the lower the rating. Then again, more sensitive sensors are more affected by the vibration interference. Then we will see that various type of sensors, that is torque, force, and torque, touch, force and torque. That is, tactile sensor is a device that measure information arising from the physical interaction with the environment. Tactile sensors are generally molded after the biological sense of, that is, spontaneous touch, which is capable of detecting stimuli resulting from mechanical stimulation, temperature and pain. Tactile sensors are used in the robotics, computer hardware and security systems also. The common application of tactile sensor is in touch screen devices, because whenever we are touching, we can sense the human being. Just like that, this sensor, you are touching with the mobile phone, automatically it will form a sensation and it will open whatever the function it should be operated. It will function based on that. Tactile sensors may be of different types, including piezoelectric, capacitive, and resistive sensors. Force sensors, that is force transducer. There are many types of force sensors, usually referred to as torque cells to measure torque and load cells to measure force. Force transducers are devices usually useful in directly measuring torques and forces within your mechanical system. That is, force transducer is used to measuring torque and force only. In order to get the most benefit from a force transducer, you must have a basic understanding of the technology, construction and the operation of this unique device. Forces can be measured by measuring the deflection of an elastic element also. Strain gauges, most common sensing elements of force. It converts the deformation of the change of its resistance. Strain gauge will convert the deformation into resistance. The gauge resistance varies from 30 to 3K, corresponding to the deformation from 30 micrometer to 100 micrometer. Strain gauge is mounted on the shaft with a specially designed cross section. Then position measurement. An optical encoder is to measure the rotational angle of a motor shaft. So whenever the motor shaft is rotating, we have optical encoder also. It consists of the light beam, light detector and a rotating disc with a radial grating on its surface. Grating consists of black lines separated by the clear spaces. The width of the lines and the spaces are the same. Line cut the beam and hence the low signal output. Space allow the beam to the pass and hence the high signal output. So whenever the space is there, automatically it will go inside the gap. That is the meaning of that. The train of pulses is generated with the rotation of the disc, but counting the pulses, it is possible to know the rotation angle. So I prepared this contents by using these references. Kindly go through the references, that will be useful for you. Thank you, students. Thank you for your kind attention. Kindly subscribe the channel. Kindly share this video to your friends. We will see in the upcoming videos. Thank you one and all.